In number 20, we could use a shortcut here because these are conjugates. But just to show you, I'm going to distribute the x. That's going to be an x squared minus 4x. I'm going to distribute the 4. That's going to give me a plus 4x minus 16. And now when I combine like terms, the negative 4x and the positive 4x cancel each other out. So it just leaves me with an x squared minus 16, which is our difference of squares. Okay, I can do the same thing with the next one. I distribute the 3x, which gives me a 9x squared plus 21x. Then I distribute the negative 7. That gives me a negative 21x minus 49. When I combine the like terms in the center, it gives me a 9x squared minus 49. Once again, it gives me a difference of squares. And keep in mind that we could use a shortcut to skip this middle step. But if you're not familiar with the shortcut, I would recommend just distributing. Okay? If we take a look at number 22, in number 22, we want to factor this completely. So the first thing we need to do is identify the greatest common factor. So when I look at this, I look at the 16 and the 12, and the greatest common factor between those is a 4. And then from here, I have to look at the x values and the y values, an x to the 4th and an x to the 2nd. The largest amount I can take out of each of those is an x squared. And then between a y and a y to the 7th, I can take out a y from each. And now I've identified the greatest common factor. Now I have to divide it out of each of these terms. Because remember, factoring is the reverse of our distributive property. Distributing is multiplying in. Factoring is dividing it back out. So if I do the 16x to the 4th y divided by a 4x squared y would give me a 4x squared. Again, 16 divided by 4 is 4. X to the 4th divided by x squared is x squared, and then y divided by y is 1. And the same thing with this next piece. The 12 divided by 4 is a 3. X squared divided by x squared is 1, so I don't need to write it. Y to the 7th divided by y to the 1st is a y to the 6th. So again, we divide the coefficients, subtract the exponents, and now this thing is factored completely. Taking the same approach with this next one, I have to find one for all 3 of these terms, the greatest common factor for all 3 terms. So when I look at the numbers, I'm looking at a 6. That's the largest number that divides evenly into each. And then between an x to the 5th, an x to the 3rd, and an x, the thing they have in common is one of the x's, so an x to the 1st. And now when I divide that out, again, I divide the coefficients, I subtract the exponents. That's going to leave me with a 4x to the 4th minus a 3x to the 2nd plus a 2, and that's it. So remember, factoring means dividing out that thing that we would have distributed. The next one, it says the rate of change is constant in each table. And really, I've got a little bit of a typo here. This should be boxes. Because we're talking about boxes of widgets. So the cost of a box of widgets for a given number of boxes. So rate of change literally means that we're looking for the slope here. So if we're talking about the slope, we're talking about how this increases. Over here, it's increasing by 1 each time. Over here, it's increasing by 10. So this is the change in y is 10. The change in the x's is 1. So the slope of this is 10. Okay, so the rate of change is 10. And that gives us the price per box. That's what the rate of change is giving me. The price per box. Okay? Number 25, it says a baker makes donuts by creating a round piece of dough with radius of x plus 3, and then removes a hole of radius x plus 7. What is the area of the donut? So the first thing I would do is draw a picture. So here's my round piece of dough, and that round piece of dough has a radius of x plus 3. And then he's going to remove a piece from the center. So if we remove a piece from the center, it's this guy right here, and that has a radius of x plus 7. I suppose I should have used a different color there. Let me say this piece right here in black is the x plus 7. Okay, so what I need to do is I need to find the area of the whole circle and subtract the area of that piece that's getting removed. So the area of a circle, that's pi r squared. the entire circle is the x plus 3 squared. And then I have to subtract the area of the smaller circle, which is the x plus 7 squared. And now I just need to simplify this thing. So I simplify this. That's going to give me a pi x plus 3 squared is x plus 3 times x plus 3. And make sure that you're using your distributive property here when you do this. The x plus 7 is x plus 7 times x plus 7. So that's going to give me a pi x squared plus 3x plus 3x plus 9. Here, this is going to give me an x squared plus 7x plus 7x plus 49. And now from here, I can do two things. I'm going to factor out the pi, and I'm going to combine some like terms. So when I factor out the pi, essentially, if I were to remove this piece and take those away, what I'm left with is these two trinomials, the x squared plus 6x plus 9 minus the other trinomial, which is the x squared plus 14x plus 49. And I know how to subtract two trinomials. I simply subtract the like terms. Let's see if I can give myself a little more space here. So when I subtract the like terms, the pi once again stays on the outside. X squared minus x squared is 0. 6x minus 14x is a negative 8x. And then 9 minus the 49 is a negative 40. And that's it. I could leave my answer like this, or if I distribute the pi back in, it'd be a negative 8 pi x minus a 40 pi. And that's it. For this last one, it says a square painting is surrounded by a frame. The outside edges of the frame are x minus 5 inches in length, and there is a 6-inch border between the painting and the frame. And we want to know what is the total area of the border. Okay, so there's a 6-inch border. So in other words, this 6 inches is this piece right here. This is 6 inches wide between the picture and the frame. And it's the same thing here. This is 6 inches wide, and this piece up here is also 6 inches wide, and this piece over here is 6 inches wide. So we have 6 inches going the whole way around this thing. That's the border that we're seeing. And that's what I want to find. I want to find the area of this border. I want to find what's in here. And so really I need to take the area of the larger square and subtract the area of the smaller square. And the area of the larger square is simple. I take x minus 5 times x minus 5. That's the area of the larger square. But then the smaller square, I don't know what the side length of this square is. The only thing I can do is compare it to the area of the larger square. And think about it this way. The distance from here to here is x minus 5. So how does that relate to the distance from here to here? Well, the distance of this smaller square from edge to edge is 12 inches shorter than the distance from the outside of the circle, because this is 6 inches right here, so it's 6 inches shorter on this end. And this is another 6 inches right here, so it's 6 inches shorter on this end. So in other words, the side length right here is the x minus 5, but minus another 12 inches. It's 12 inches shorter than the side length of the larger square. So that's going to give me an x minus 17. So that means that each edge of this thing is an x minus 17 in length. So if I wanted the area of the smaller square, I have to do x minus 17 squared, which is x minus 17 times x minus 17. And again, I want to find the area of the border, so I have to subtract these two areas. That's going to be an x squared minus 5x plus 25. Minus, here that's going to be an x squared minus 17x minus 17x, and then the 17 times 17, which is a plus 289. And now I'm going to combine like terms inside of each of these. And now I want to subtract these, and my recommendation here is to distribute this negative and then combine like terms. If you distribute the negative, everything becomes addition, and that's going to help us avoid some sign errors here. So it's going to be a minus x squared plus 34x. I wrote a 44 like a crazy person. Let me try again. It's 34x minus a 289. And now I just have to combine like terms. Now it becomes addition. The x squared minus x squared when I combine these gives me a 0. The negative 10x and the 34x gives me a positive 24x. And then the 25 minus the 289 gives me a negative 264. And that's it. That's the area of that border. I take the area of the larger square minus the area of the smaller square. Okay? Hope this was helpful, and good luck on your test tomorrow.